Okay, hi, good morning, good afternoon, good evening, everyone. So today is our final class. So today we will discuss about what is OpenSSL, what is the use of OpenSSL, and then I'll show you the multiple way of deploying. I think OpenSSL comes as a built-in package in Kali Linux. That's something I have tried in Kali Linux. I don't know about Ubuntu. When you're doing a lab, even I would suggest use Kali Linux because you have your Wireshark and you can do you have a built-in tools. So you can make use of Kali Linux for it. So it has a built-in Wireshark, it has a built-in OpenSSL tool. So I'll also show you if you don't have it, you can also use your free AWS account where you can spin up your Ubuntu. There you can do your OpenSSL testing. That also helps you to have a foundational understanding of how you build your AWS and simultaneously you can learn your SSL. That's my recommendation. That's a free account. You can create your free account. I think for 1 year access, so you can play with AWS and simultaneously you can practice your OpenSSL there. On top of that, we will do an use case. We will see how the SSL decryption profile should be created in the Palo Alto, right? And then we'll take a capture, right? That is a broken TLS connection. I will walk you through those PCAPs and how do we find those kind of problem, right? If even if you don't have any explicit error in the Wireshark, but still, how do you find it's a problem with your TLS? That happened to me many times. Sometimes you don't see that explicitly. It's because of a certificate issue, or it could be something else, right? So if your TLS connection is not happening, there will be multiple reasons. Example, your certificate may be corrupted. They may be using a wrong key. So multiple factors. But just by looking into the use case and looking into the Wireshark, right? You see your TLS handshake successful, but there is a reset from the client connection, and we'll see who resets the connection and how it is happening and how in that particular situation how we can find a problem. Yeah, that's something we have in the list today. And then finally, we will talk about a little about voice, not much, and how Wireshark can also decode and how we can inspect the packet, voice packets in Wireshark. A little voice stuff, the final, because I mean, I think one of the students he suggested to do a little training on voice. So that's something we have for today. So for that, let me quickly share my screen. One second. So let me log into the jump box. So I'll give you a little background about this OpenSSL. So when you maybe you guys have created multiple CSR, but why we want to learn OpenSSL? I'll give you a little background about that. So OpenSSL tool, it's a free, what is it? It's a free application where you can learn how to create your RSA keys, not only RSA, your elliptical curve key, EC keys, how this is created, right? Uh, I mean, it was a mystery for me when, I mean, to understand how this private key and public keys are created, how the certificate is handling this public key and private key. And since we are all working for TLS, troubleshooting, if you understand at a very deep level of how this private key and public keys are created, so that really helps for your troubleshooting. Yeah, because we know the certificate, but I feel like, I mean, I mean, when I started, I don't know what is the certificate standard, and we know what is private key and public key, but how this public key and private key is created and what is encryption. We know what is encryption, but when you exactly apply the encryption algorithm, something like AES 256, so when you apply an encryption to a key, how this is created. So how to create a public key, how to create a private key, how this is exchanged. So this this helps you to troubleshoot better. Not better. It helps you to figure out where the problem is, right? We create a CSR. We know that, so we all doing it for ages. We are doing it as a CSR, but I think how this exactly the how this public key is created when we are doing something, right? When we are doing something, we just create a CSR and we'll hand over to the server team, whomsoever is handling it. But we don't think about how this is exactly created. So we should know how this public key and private key is created, how this algorithm works together. So for that, your OpenSSL helps a lot to understand this. So when you create a key, right? When you create a when you create a certificate, what are the three components? First, we will create a CSR, right? Then you create your private key. Then you will give this. You don't give your public private key to anyone else. You'll keep it safe, right? And you will give only your CSR to your CA, certificate authority. Example here it is GoDaddy, right? He will sign your certificate. Along with the certificate, you get your public key. Since we are not doing anything with this, all we are doing is we create a private key, we create a CSR, and we are giving the CSR to the certificate authority. You get your certificate signed, and you will get a certificate for it, right? So all you're giving is a CSR, and you will get a certificate. And when you are installing your certificate, you will be mapping your private key with that. But what is happening inside? This is the steps we do. But when we are troubleshooting, right? When you're troubleshooting, somebody is giving you a certificate. Example, your device. I have seen. I think Netscaler we had a problem with a dev format. Whereas if it supports only the .pim or .crt format, how do you change? How do you convert your format, your certificate format from DER to PERM format or from PEM to CRT format? How this conversion can be done? So you can play with this. OpenSSL is very powerful. There you can learn about everything. So you'll learn about what is the certificate type. So this helps you. You don't want to depend on the other team to do this when you have a problem. When you want to extract your public key and private key, I will show you how to extract the public key and private key, how to extract your public and private key, all this. I'll walk you through the practical session, but this is the background about that. So we create a CSR, we create a private key, we hand over the CSR to the certificate authority. It will get it signed from the public CA, so that the public root CA cert is installed in most of the computers, so it's going to trust your certificate. It's not that you can go to every PC and say, I am a I'm the legitimate user, you can trust me. No, nobody can do it. So it is someone who is who is globally who is governing everyone, and if he signs and stamps your certificate, so that all the client PC can trust, because all this operating system that comes with built-in root certificates, and also your Windows have this certificate authority store where you have all your root certificate. We know that, right? So here, generally what happens if you create your certificate, when we say self-signed certificate, there are two options, right? Self-signed certificate, that's something we use to for all most of your HTTPS connection, because that is purely used internally. So nobody wants to trust your certificate. So you create your certificate, and you will be your certificate authority for it. You are going to sign this cert, but you get an warning, right? This site is not secure because it doesn't have the root certificate in the certificate authority store. So this is the very basic. We know this. But here with OpenSSL, what we are going to learn today is that how we can create a private key, how it is created. You can see the algorithm, how it is created, what is inside the private key. But it's an again encrypted, but you can see private key and how this public key is created, how this is encrypted. So how if you want to extract your public key from the private key, how to do an extraction, how to see the content of the key, to view your certificate, to view your key and everything. We will do that. So as I said, if you want to do an OpenSSL, there is three way you can do it. The best way is, I would suggest, it's Linux or Ubuntu, or you can use, as I said, you can do your AWS, and then you can run your Linux box there, and you can practice your OpenSSL. This is a freeware, as I said. It's a bonus video today. I mean, I'll just show you how this AWS account is created, and a quick walkthrough about the AWS and how you can spin up your Linux. I'll show you how to do that. You guys can try that if you want to practice your AWS, a basic AWS, and your OpenSSL. And there is an option to do it in your Windows, right? But that's something we are not going to cover about this Windows. We are going to cover only the Linux part of OpenSSL. So this is the tool. So with OpenSSL, you can also you can run the certificate authority service. Yeah, you can make your OpenSSL as your certificate authority, so you can sign your certificate. That is also possible. I'll give you a cheat sheet for you so you can practice that, right? So but the base, the foundational, what is the essential commands and the essential, how to say that, the essential parameters of OpenSSL is something we are going to cover today. So let me open my agenda box for it. So this is the tool. It's all purely a command based. You have every, you have all the options here, and you have a proper description and how to do that. And also I will walk you through how to do that step by step. We're not going to cover everything. As I said, the essential what is needed to troubleshoot the TLS. That's something we are going to cover today. So let me open this. Palo Alto. So when you open the, what do you say, the Kali Linux, as I said, right? You don't want to do anything else. You can check that your OpenSSL, it works on your Kali Linux. If you give OpenSSL tab, yeah, so you'll get your OpenSSL. So I didn't do anything. It is built in inside the Kali Linux. So you can make use of this OpenSSL tool in the Kali Linux. Yeah. So first, let me walk you through the what we are going to do today, right? So we are going to create an RSA key with encryption, and also we are going to create a private key and public key, right? And we are going to verify this, and I'm going to explain every step, how to see that in the text format and how to exclude the PEM format and what is modulus and exponent. I'll walk you through everything. Yeah. So to do that, the command is OpenSSL. It means that you're running OpenSSL. Gen RSA stands for you're going to generate an RSA key, and the output should be key2.pem. You can give any name for this. And if you attach your encryption, it's going to encrypt. So we are using AES 128, and the encryption strength is 4096. It's a key size. The higher the key size is, better is your encryption. There's also, we have to think about the CPU. So it is a CPU intense task, but because for every encryption decryption, if your key length is higher, it takes more time, and also it is a CPU intense task. So when you're practicing it, I would suggest you to use a very minimum key size. Don't go with a higher key size. Just try with the minimum key size, right? And we are going to use a cat out command to view and to see what is inside the key. So now let's see here. This particular command is, I'm going to create an RSA key with encryption. If you don't want to create an encryption, you can get rid of these two because this defines your encryption. So if you don't want to define your encryption, so you can get rid of this command. You don't want to define your encryption. So let's create a new key with this. Yeah. So I'm going to copy this command. So let me copy that. So instead of this, I'm going to create a new key. So as I said, I'm telling OpenSSL generate RSA key, and the output, my key file should be the name, the user defined name, what I am giving here. And this is my encryption, and this is my key size. So I'm going to give this as a key 3 for consistency. What if I'm going to create this key without encryption? So I want this to be in PEM format. As I said, you have two formats and multiple formats, but most widely are PEM and DEV format. So it is generating a private key, right? This is without encryption. And if I want to see what is inside, if I want to do it, I want to do a cat out command, cat to see in Linux, copy this, paste this. So you can see there is no encryption header here. So you created a private key. This is just a hash, not encryption. That is the difference, right? For encryption and decryption, you need the key to open it, but this is just a hash. We are not doing any encryption here. But say, for example, if I want to create a key with encryption, so I'm going to say key 3 with encryption, ENC. Let me give a name, hyphen here, with encryption. I'm going to give the command AES1024. There is a syntax error here. I have to give hyphen there. You can have your scripts side by side. We don't want to master the syntax here. The whole logic is we have to understand the concept. Yeah. So I'm giving with encryption now. That is without encryption. Now I'm giving this with encryption. If I press enter, it is creating a key with encryption. But if you want to do with encryption, you have to give a passphrase. So I am going to give this passphrase as key 3 to remember. Key 3, enter. I want to type it again. Key 3, all capital same. It is done. So if I do a cat now, this is with encryption, yeah, that is without encryption. How do I differentiate with encryption and without encryption? Dot them. So you can see this additional header, right? So you can compare your output. This is encrypted. This key is encrypted. It is using AES-128 CBC. So this is how you encrypt your file, and this is recommended. This is how you create your private key. So if you remember, when you do a private key, you always give your passphrase. So that over the email, if you send, if somebody wants to open this particular private key, he should know the passphrase. If he doesn't know the passphrase, he can't open it. Right? If you remember, when we created the key, it was asking for the passphrase when we created, right? So I gave this passphrase here. So without the passphrase, you can't open this file. So when you transfer this file, especially when you get your file, or if you want to send this file to someone over the email, it is always recommended to create a key with encryption. Most of the time we are doing that. We are not doing without encryption. So sorry for this. This keep popping in because of some error here. I tried to stop it, but still it is coming. Bear with me. So that is how you can create your private key with encryption and without encryption. And you can see this, and you can't see anything inside. So for now, let me give a quick Q&A session for this, and let me know how if you have any questions, you can ask me. So I'll give a quick unmute permission. Yeah, I gave an unmute permission for everyone. So you can ask your questions if you have any questions. Asad, Meeraj, Nilesh, Santosh, Vital. If you have any questions, you can ask me.
Yeah, hi Praveen.
Yeah, yes, Meeraj. Meeraj, right? Who's talking? You guys can't talk. Yes, Meeraj, you said something?
Yeah, can you hear me?
Yeah, now I can hear you. Yeah.
Yeah. So normally we create the CSR from the load balancer.
Yeah.
When we create the CSR, so it will not show private key. It will just give us the CSR value. So
Is it
that
what
case,
load what load balancer you're using?
like F5.
But generally, you have to map your private key when you are installing the certificate, right? When you create a CSR and give it to them, and there should be an option to create a private key for you, right?
No, actually, it is not. While creating the CSR, it will not ask and it will not show also.
No, no,
Only
not
it
for
will show.
no, you are right, not for CSR, but you have to create your private key to map your with your certificate, right?
Yeah. So what will
Uh,
happen when
mm-hmm.
when we get the certificate?
Mm-hmm.
So when we upload the certificate, then it will show private key and the certificate both. But
Correct,
while
correct.
creating the CSR, it will not show.
No. I'm not telling while creating the CSR. I'm telling the process. I mean, you have to create your CSR plus your private
Mhm.
key separately. So once you give the CSR to the CA, he will sign and give it to you. And then when you are installing your certificate, you have to map your private key with your certificate for installation, right? Otherwise, it won't work. Yeah, that's a mandatory
So I
thing.
think, yeah, so FI will do automatically this one through a
But
browser.
is it? But how do you map your private key? You don't map your private key with your certificate when you're installing it.
Yeah, so when we create the CSR, we give CSR,
Okay.
then they will provide us the certificate. So we'll
Okay.
upload the certificate. So once we upload the certificate, then we will get both on the same. We'll not see the
Private key.
CSR is separate. Yeah, then we'll see private key as well as certificate both together.
But from where your private key you will get your private key when you have an option to attach with your cert. How do you do that?
We will see only after we upload the certificate. Before that, we'll just see only
Yeah,
CSR.
that's I got it, Meeraj. But where you will get your private key at the time when you want to install? At the time when you're installing your cert, you it's a mandatory option there to select your private key, right? To pick your private key to attach to the cert.
Yes, yes,
Then
yes. That is
how?
correct.
Yeah.
Yeah.
But how do you get that private key? Is it something you have to create, right?
Actually, on load balancer, we will not create separately
Mm-hmm.
as a private key. We
Mm-hmm.
just create the CSR
Okay.
and we'll provide the CSR. Then we will get the certificate.
Okay.
When we upload that certificate to the
Mm-hmm.
CSR,
Okay.
then we will get. Then it will show key as well as certificate. I mean, private key and the
Oh,
public key both.
oh, you mean to say it extracts a private key for you and give it to you when you're installing it?
Yes, yes, yes. Yeah.
Mm-hmm.
So maybe it is a background process. It will
Mm-hmm.
not show to us. What
But
we see only
okay.
the CSR.
Mm-hmm. Got you. But this is how it is created. This is how your private key is created. Generally in Netscaler, what happens when we are creating a CSR? We will create a CSR and also we'll create the key. And the
Uh-huh.
key, it is saved locally in the Netscaler. So once we got the certificate, so when you are
Mhm.
installing the certificate, it will ask you three options. Your certificate, then your private key, then your passphrase. I shown you, right? When you are doing an encryption, you are giving the passphrase. I have to give the same passphrase when I am attaching my private key with cert. Maybe in your case that works a little different. I don't know how it works there,
Yeah,
but
yeah, yeah,
this is
yeah, yeah.
how in the generally this is how it works. I mean, even in Windows when they are installing it, they have to attach the private key. Without the private key and passphrase, they can't install the
Mhm.
security. Say for example, you're creating a CSR from a Windows machine, and it can be any server. So when they are installing it, they need the private key. Only then they can install the cert that particular in the particular server. That's how it works there. So
Yeah,
this
yeah.
is
Okay.
the whole process. I mean, creating an RSA key. is different. The same logic applies when you're doing an IP sector, right? When you have your encryption, when you select your encryption, your what is that? Mm, your defilement group, when you define those keys are used like that. The logic is different, but the process remains the same. This is how it is encrypted. A key is encrypted. Yeah.
Yeah,
So
yeah, okay,
now
got it. Thank
inside
you.
now yeah yeah now inside this key you got your public and private, and I'll show you how to extract that public and private from this now, and how
Okay.
this public and private keys are created. Yeah. Okay. Fine. Do you have any other questions, guys? Asad, Santosh, Vital. Give you 2 more minutes. If there is no question, then we will jump back. Asad, you have any questions, Asad?
Yes, sir.
Yeah,
So
yeah.
could you please show us in the Palo Alto device also how? So we know how to generate I have the also the same question. We know how to generate the CSR, but while
Okay.
generating the CSR, it does not ask for the private key. But when we are importing, it
Mm-hmm.
is also asked for the private key. So
Is it? 1 second here. I think we'll go back to this. You see, I don't know about this process here. Certificate I have downloaded here. So how to patch? I need to generate the private key to use with OpenSSL. You can generate it. I don't know how you guys are creating that. Maybe I have to research on this and I'll ping you in the chat. I don't know how it is used, but if you generally see in the Netscaler, private.
So basically, actually, the process, Praveen, look like when we create any, when we want to create any cert, that time we have to create a CSR. Okay, while the
Mm-hmm.
CSR, that means when we generate the CSR, so that time that CSR automatically bind the private key. Okay,
Mm-hmm.
and when we once the CSR generate, and after the export that file from the device. Okay, so that time also you can see that private key with the
Mm-hmm.
CSR. Second thing, when you click the CSR, whatever you generate the CSR on the device, so it will show the two, three options. Okay, the first tab, the upload related means the cert related information. The
Mm-hmm.
second tab, it is showing the private key related information. Similar for the FI also. Okay,
Mm-hmm.
when you create any CSR, so both CSR means private key and the CSR related information both are showing.
Mm-hmm.
Okay, so they
Okay.
automatically process happen background when you
Okay.
create any CSR.
Okay. Okay, got you. So, Nilesh and everyone, if you look at this, even when we are creating the CSR, right? So when we create a CSR, this is a CSR file, and this is a separate key file. We have to attach like this. What is the hashing you're using, your all the other parameters of your CSR, And along with that, when you are creating a CSR, you have to define your key file. We will be creating a key file separately like this. In the top, you can see, create your RSA key. This is something we did in the OpenSSL. We created this in the CLI. So you have to define your algorithm, your encryption. Here the encryption is AES and the key format is PEM format. And this is the key size. So I don't know, maybe that is a bit different there. If the private key is encrypted, you should use your passphrase for it. The same thing we did there. So I will research that and let you know how it is created. You guys also can research that. But definitely without the private key, you can't install your certificate, because the person who is the owner of the certificate always has the private key and it is not given to anyone else. Without the private key, what the what do you say, the receiver, or maybe the your remote peer who is trying to establish a connection, SSL connection with you, if he doesn't have a public, if he is encrypting the data with a public key, because you will hand over your public key to everyone, whoever wants to establish a connection with you, if you own a certificate and you are the SSL server for it. And if he doesn't have, if he is sending something with the encrypted, and if he's sending back something to you, to decrypt the data, you need that private key with you. That's the whole point. So that's why we are creating a private key here. The logic remains the same. Maybe the implementation part is a bit different, but the whole point is you need your private key, your public key, then your CSR and your certificate. All these are essential elements. Without your CSR, you can't get your cert. So once you get your cert, you should have your private key and you will hand over your public key to the clients who tries to connect with you. So coming back to the lesson. So we have seen how to, let me go back to the next box. So we have seen how to create a private key. And I want to show you how to differentiate the private key and public key here, how the public key is created when you create your key. So whenever you're creating a key, this is, we are creating an RSA key, right? So if you want to see the content of it in the text format, so you have to use a command OpenSSL RSA key, and the input key is the feeding. You have to feed your key. The key there, we are using key3.pen, and it should be, you should you should view your content in the text format. So that's the whole meaning of this. So let's copy this command and let's see how it looks in the text format. What are the contents inside that? So it is, first we have to give ls. So we created this key3 with encryption PEM. So I'm going to replace this with this file name. I am doing something wrong with the command. It is key3.pem, right? Oh my god, I screwed up with command here. So I have to give the passphrase for it to see the content of it. Key3, key3. So earlier we didn't see this coefficient value, exponent value, the prime values. This is used to create your public key. So once if you see this is a public exponent. And if you go back to this command line, so your modulus and the exponent values combines together, that gives you a public key. So when you are creating your private key, right? So this what happens, right? So you want to go a little deep about this. So when you have your certificate, when you got your certificate, you should see something like your public key on it, but that is encrypted. Encrypted with what? The same key what we used, that is encrypted using AES 128. We are encrypting this and we are sending this certificate back to them. They have this public key, but how this is created? This is how it is created. When you're creating your private key, that also creates your public key. That is the component I told you, right? So inside the private key, you have your exponent and module that combines together, that goes through the mathematical operation, and that creates your public key. So go back to this, go back to Windows, and let's see this example. Connection is secure. Want more information? And Meeraj or someone, I mean, long back they asked, this connection is encrypted. See, this is encrypted using TLS 1.3, right? You have to go for in the Linux, you have this option. If you click on this pad icon, you can see what is the algorithm they used, the other end. To give view certificate. Once again, actually, I missed that part. So I have to click on the pad icon. I want to go for more information. There you will see this is a TLS connection, and it is using, they are using AES encryption, and they are using the SHA hashing, and this is using TLS 1.3 key encryption hash. So you can see that how exactly the communication is happening, and this is 128-bit key. And if you view your certificate, a bit different. How does it shows in Windows? Once again, let me check this here. You can see your public key here, right? There, I don't know, in Unix it shows different. So this is your certificate, it's hashed, and you have your public key. So my computer is encrypting, decrypting based on this public key, right? And this is this public key, right? Whatever encryption I'm doing, only the server which owns this private key. Because when you create a private key, if you have seen, we are also there is an additional component. Only the person who holds the private key has the public key. Even somebody is trying to hack this, if somebody is trying to get this key, he can't do anything with that, because he is creating the public and private key and he is giving to you. Only the person who has the private key can decrypt it. So he can't do encryption and decryption with this private key. Yeah, because the key material, whatever we did for this whole process, is something happened only with the private key. The person who holds the private key has the complete control of public key and private key together. That's why the private key is so important. That's how it is created. Now let's see how do we extract the public key and private key from that. So here we are using a different key. It is key3 with encryption.pem, and I am telling that I am feeding a key OpenSSL RSA. In the input is the key file name, and the pub out means it will extract your public key, and you can give any name for it. This is the output of the file. So it is telling that you extract the public key out of this, and the output should be the name, whatever you want to give, you can give it to extract your public key. But to extract your public key, you need your modulus and exponent, both parameters. Yeah, if you look at this, this is your exponent, and if you scroll up, see, this is your modulus. So with these two values, right, with your modulus as well as with your exponent, public exponent, it creates a public key for us. So we don't want to go this deep level. This just I am giving a complete insight, a deep understanding of how this public key is created from a private key. So if you go back, and copy this command, the syntax is bigger. Let's copy this command, go back there. You give an ls to see the files. I'm going to paste this command. So I'm telling OpenSSL RSA, the input key file is. This should be the valid key we should have inside first. This is the key we created. Pub out, and I am telling this. This is key3 pub, public key. So I have to give my passphrase, same key3, all caps. So if I give ls, you can see key3 pub.pem. So now if I do a cat out to this particular key, so if you see this, this is a public key, end of your public key. It's completely encrypted. So now we have successfully extracted your public key from the private key. If you look at this, this has your public key and private key. To create your public key, you need your exponent and module. So with the exponent and module value, right, you see your public key here. This is how you can extract your public key. If somebody is giving a private key, and if you want to extract the public key, usually what happens, they will create a certificate. And if you want to extract your private key from that, I have experienced that. That's when I started using this OpenSSL. So I had a problem. They had something like a DIR format. I have to convert this back to the PEM format, and from the PEM format, I have to extract the private key. And we did that. So we don't want to depend on any other team to do this. This extraction process and everything, we can do it. And also this helps us to understand how this public key and private key works and how to extract, right? This is an additional skill you can develop when you're doing your troubleshooting. So this is how your public key and private keys are created, and you can see that using the cat out. And also, if you want to do your if you want to see the supported algorithms for your public key and the cipher suites, you can give this command in your OpenSSL. OpenSSL list public key algorithms, supported public key algorithms. You can see all this. We are using PIM with RSA. You have a DSA, you have Diffie-Hellman, lot of algorithms you have. So you can play around with this, and also I will give you this cheat sheet. So this helps you to work on better, right? So this is a far minimum what you want to really understand how this private key and public key is created. So now we understand how this encryption decryption happens and what algorithm is used. So when you're troubleshooting, it will give more insight about that. So now coming back to this Palo Alto decryption, we'll take a PCAP and I'll show you that. So we will talk about how this encryption decryption profile should be, how it will be created in your Palo Alto. Before that, let's take this capture and let's analyze where is the problem. Yeah. So for that, let me open the Wireshark on it. Okay, this is already, we captured this packet. We will do that one more time. So, okay, so this is a traffic. I will do it. We'll do a live capture and see. So let me go to application. Where is that? This usual application, internet, and my Wireshark. What's happening? So I have a Wireshark open here. Go to the top. There is my Ethernet 0. So now let's go back to the application, go to Firefox. Is it different, Firefox? Okay, so now let me generate some traffic here. So now in the topology, what happens here? This guy is 30002, right? 30002, it's trying to connect to 30001. So here I am doing, since I'm doing an SSL decryption, I'll okay, there are a few guys, they may not from the security backgrounds. I'll give a little background about this SSL decryption in Palo Alto. So this is your Palo Alto. So we are using a forward proxy. So that this is something like man in middle, MIM. So this is the client. And this is the server. So generally how your TLS handshake happens, you should have the server certificate here on the client. Example, the server is server X. So I should have this, whatever the certificate the server X has, it should be signed by a CA. I should have this root CA in my computer of server X. Example, in this case, it is example, take same example, GoDaddy. He signed this cert. So I inside my root CA, this client, I should have this GoDaddy. GoDaddy root cert. I should have. But instead, what I did, I have enabled the forward proxy and I enabled the SSL decryption profile here. For this SSL decryption profile, I should create a self-signed certificate. And now I am blocking the unknown root CA in the policy, in my decryption policy. So whatever I see the unknown root CA, that is blocked. Block the unknown root CA here. So this is how the profile is created. So now I am trying to do a capture, packet capture. So I am trying to connect to, for this is applied for all my, what is it, in the decryption profile, I am telling that the traffic coming from inside going to outside zone. Block the unknown root CA. So now, since this is a self-signed certificate, my PC doesn't have the root CA of my Palo Alto because I did a self-signed certificate. So I need the same root CA cert here. Otherwise, it's not going to trust. So this is how we did. So we created a cert and we created the forward proxy here. So we are decrypting the traffic. Now this client is trying to establish a connection with Palo Alto, and let's see what happens there. What happened here? I think one second here. Why this has changed? Cannot read properties undefined reading status. Was working fine this morning. Oh, it works still, let's say, okay. I had a little hiccup with this now. I want to show you that. Okay, let's come back to that. It's fine. So there is some problem with the login there. I don't know, it worked since now. Okay, so when I do a packet capture, right? So when I do a packet capture, so it is that I will see, usually I will see this SSL handshake goes through. I'll erase this and I'll show you this. So I will see the SSL handshake happening there. First thing, and the second thing is I see client hello, then I get the server hello back. So I see the SSL handshake, I see the client hello, I see the server hello, but there is a reset from the Palo Alto. That is, in that case, in our topology, we know that is 30002. So here, this is the Palo Alto, that is 30001. And this is my client PC. It tries to connect 30001. Who will do a reset? The 30001 will do a reset, because this client doesn't have that certificate. But you see your client hello, server hello. I'll try to send a capture after this class, but that's how exactly it works there. So once you create a SSL decryption profile, once it goes for the TLS, that's how the certificate plays a vital role there. So you should understand every component of your certificate. So just by looking at your client hello and server hello, and also if you don't see any kind of error related to your certificate, don't come to a conclusion. If somebody is doing a reset, who resets the connection and why it resets? So you have to look for all the parameters in your certificate. And as I shown you before in the previous classes, if something happens with your encryption, your hash, how do you verify? Now you know that if you expand your options, we discussed this in the previous classes. In the extensions, you can see your TLS supported versions. Most of the time, if the client is proposing the lower TLS version, and if the server just support only the higher version, always look for the higher version. And if the server doesn't support the lower version, it's going to break your TLS connections. So these are all the most wide troubleshooting and most use cases we have for the troubleshooting, and I would say the most common problem we encounter with. So when you look for that, you have to check for your certificate validity. Sometimes that is very important. If you have your expired cert, your connection will not be established. So when you are doing a SSL handshake in the client hello and the server hello, you should also look into the extension. You should see it is valid through, you should check your validity and your expiry, and everything you have to compare. So in this example, it is valid 10/20/21 and 2020 May 10, 2021. Even if you try to log in on May 11, 2021, example, in that case I'm telling, so it's not going to work. So when you're troubleshooting, the key thing you have to look for is your validity, right? Your encryption standard, your TLS. Then you should have your root certificate. It's all the key components there when you're troubleshooting with that. We discussed a lot about this in the previous classes. And then followed by this, I will show you how this voice traffic, how do we inspect the voice traffic in Wireshark. One second, let me quickly extract this. So this is the PCAP I have taken from a voice. So there is a separate option in the Wireshark. That's something called as a telephony right over here. So if you just click on this telephony, go to your RTP, check for your RTP streams, because we all know that the voice traffic is predominantly using the RTP traffic. So this is the conversation. If you see, this is the conversation from 10.1.1.1. This is purely a voice over IP. So they are using an IP connection for it. And the payload is, they say it is a Kodak. Yeah, there's not much we have to know about. I'm just telling this because if somebody is working on the voice, how the Wireshark can see that. So this is the Kodak, it is using it, and the duration of this call, how long it is up and running there. You can see that you can see the minimum jitter, maximum jitter that comes for your when you consider your slowness. Then out of 733 packets, there is no packet loss. And also you can't listen this there, but you can also play the stream. You can listen to what they are talking about, what they are talking, because this audio codecs, this is something the Wireshark can do this for you. You can listen to this audio. So get a proper permission to play around with this. And I would again suggest, since this is a voice traffic in the corporate, I don't know, it's a privacy related problem, security problem. So get a proper confirmation and get a proper approval and to work through this. This is the sample capture I have downloaded. I will give you this capture. You can try with it. That's the best way of doing it if you are interested to see that. And this is a skinny protocol, they say. It is between the server. If you look at the subnet 10.1.2.1 and 10.1.2.2 is between the clients. And the skinny protocol, it happens with their CUCM server. So it uses a skinny protocol between their CUCM server and the client, whereas the RTP predominantly for all the other traffic is for RTP traffic. And also the Wireshark can decode your codex. They say it's a codex when they are talking, some translation it does. So it is showing that the codex is G.711 is the codex it is used for. And here also in the real-time protocol, if you open this payload, it's all completely hashed and encrypted. We can't see what is there inside your RTP packet. Then you have a list of other options, SIP flows, SIP statistics. You guys can go through that who are working in voice. So this is how you can use, there is a separate field here for your voice traffic. So you can make use of this and you can troubleshoot your problem. We are not going too deep about voice. So now let me show you how you can use your OpenSSL if you don't have an access to Linux or if you want to play with that. I'll give you an option to do that. Let me quickly open this and I'll show you. This is my cloud account I'm practicing for my AWS. One second here to do some changes. I'm going to log in this. A quick run through with this, yeah. So I'll show you what we can do with this. So it's pretty much simple as if you know networking, the fundamentals. So maybe some people, they may be working in cloud. So they say it is a virtual private cloud. There you will use your supernet. You can do anything like 10.0.0/16, right? Then you create your subnets. Then you create your internet gateway. There's multiple way of doing it. But if you don't want to do a NAT, but if you want this private IP to reach the internet anywhere outside, it is just the VPC example. I'm giving a number 1, 2, 3, 4, 5. So whenever you create a VPC, you will be given with a number. It is auto generated by the, what is that, in the Amazon AWS. So once you get this number, you have to attach your subnets, you have to attach everything is like you want to attach. That's it. So once you create this, right? So once you create this, and if this your private IP address has to be routed to the internet, you have to attach your subnet to the internet gateway. So once you attach to your internet gateway, it automatically assigns your public IP address to it. So other than this, it cannot be routed. There is two way, right? So one is your internet gateway, another one is your NAT gateway. So I deployed in a way that it is using a internet gateway. It is like a source NAT. So whatever the traffic that comes from the local subnet, right, that hits the internet gateway, it goes out with this public IP address out to reach wherever you are trying to reach. So in the destination NAT, it is a bit different. We are not doing that here. And then with the same subnet, my subnet, I'm going to create one more EC instance. That is like your virtual machine. You're going to create your virtual machine as a service. So we are going to spin up a Linux box. I'm just going to show you how to do that. Yeah. So you can spin up your Linux box and you can play with your OpenSSL there. And also simultaneously, you can learn a little bit of your AWS. So this is my VPC. Right, so I built this VPC on California, United States here. So if I hit on my VPC, I created this VPC with two CIDR values. If I hit this, as I said, this is auto created your VPC ID. If I click on this, you can see your CIDR values here. So if you go and edit, see this is the VPC I had, right? As I said, if I go to your CIDR, this is the first value you have to give. So once you add your new CIDR value, you can give like this. So I've added this already. One for public and one for private. And also you can have this availability zone that beyond this topic, but the availability zone is for redundancy they use, the availability zones. One, if your service are critical and if you want your web servers and it should be always on, then you can have your, they will be given with two availability zones generally there. So this is availability zone 1 and this is availability zone 2. So you can have all your public web servers here. So even though something crashes here, you still have a reachability to your another availability zone. So that availability zone is something I created there for the, what is that? What is the name for it? It is called, what is that? The terminology, EC instance. Yeah. That's something you create your EC instance and keep it on your availability zone. Keep it in both availability zones so that if something one goes down, the other availability zone will be still up and running. So that serves your connection. So as I said, here is the VPC I created. This is a subnet I have created inside my VPC. I got two subnets, one for private, this one 10.100/16 and this 10.100/16. And then we have to do subnets. So from that is your VPC, your super subnet. So on top of that, I created two other subnets here. If you look at this subnet, there is a to edit the subnets. You go and edit this. Yeah. So I created two subnet. One is 10.110/24, right? This is 10.1.101/24. So you can create your subnet. This is a predefined. I mean, I created this. So once you want to create a subnet, you have to hit here, create your subnet, and you have to attach to your VPC. In this case, this is my VPC, and you can add your subnet blocks here. So I'm not doing anything here. So you can give your name, you can attach to your VPC ID, and you can give your subnet values here. You can give the name, you can give the subnet values here, whatever you want to add, right? Here is your subnet block you have to define and attach to your VPC. Everything is just an attachment, very simple. So I got two easy zones, as I said. I created these two subnets. And coming to routing table, it's same like our router. If I go to this public route, so I did all this default route goes to the internet gateway. And this routing table here, it works like all for all my 10.0.0.1 within my VPC, it is a local route. This is all auto generated. The only route what I created here is this thing. I created default route. It has to go to the internet gateway. To create an internet gateway is again simple. First, you have to create an internet gateway and then you have to attach to your VPC. So if I open this, right, this is the internet gateway. All you have to do is you have to detach and you have to attach to it. You have to go to your internet gateway and you have to create an internet gateway like this, right? You can give a name. So once you create an internet gateway, it will create a gateway for you. So once the internet gateway is done, it will ask to attach your VPC. Then you can attach your VPC ID to it. It is auto populated there again in the GUI. So you can do that. So once this is done, right, you have to go to your EC2 instance to spin up your EC2 instance. We go to this. That we have to type in EC2, yeah. So if you click on this EC2 instance, this is if it comes with your free tier, you can check this free tier eligible. You can click on this, right? You can click on this and you have to allow your network setting. You have to allow this for SSH traffic. And also if you want to allow for HTTPS, you have to allow for both. And I am giving anywhere here, but it depends. I mean, you can be very what is that? If you want to restrict your traffic, you can do a custom and you can define the subnets, what you want to define here, the CADR, what we created. And this is for the whole. So you can create your security groups. Then you see that this is the subnet I have attached. See, this is my existing. If I edit this, so this is my VPC ID I have given. This is the subnet I created. See, this is my showing my availability zone. This is private. It can't be routed outside, but I have attached the internet gateway for it. So my traffic is routed like that. And my subnet, see, this is 10.1.1.0. This is my private subnet. That's it. And then once you give all these options here, and if you want to use with the key pair, I gave a key pair, my key pair. You can create your key pair, or else you can create a new key pair here, and you can attach to this. So once this is done, everything is done, you can launch your EC3 instance. And it opens up there. Yeah, this is pretty simple. You can do some Googling and you can get it. So this is also a way where you can create your VPC and you can have your EC2 instance and you can play with your SSL connection there. It just booms and it just works there. So what else? I think I covered this. I talked about that. Yeah, that's it really. Then I'll give you this cheat sheet there. You can practice your stuff. Yeah. And then now I will give a quick unmute permission for you guys. And before that, one thing I think I have to, okay, I want to take that capture back. Okay, I'll come back to that. So I gave an unmute permission for everyone. If you have any questions, you can ask me. Hi, Asad. Neelish. You guys have any questions?
No, Praveen.
Okay. So this is the last day of the class. So if you guys have any questions to me, if you want to discuss anything, you can discuss now. Okay. Nilesh, hi Nilesh.
Hey, hi, Praveen. Yes.
Yeah.
Sorry,
Nilesh,
I was talking.
no problem. I mean, is it okay that if I ask you a few questions that may be little, I want to make this little intuitive. I mean, this is a final class, right? So I will choose any topic and I can ask a question. Are you okay with that? I mean, how do you feel about that? If you're comfortable, we'll continue with that. Just to know how much you
Mm-hmm.
understood and how much it reached everyone. Yeah. It's not about to analyze your skills. If you're okay with that and comfortable, let me know. We'll start.
Mm. Actually, I haven't
Practice.
done any much practice. Yeah.
Okay.
So it will.
Okay, no problem. Okay.
But if you want to ask a few things, I will give try my best.
Okay, sure. Okay. Um, okay, let's take this example. When you are troubleshooting a problem, right? When related to your TCP, this is just a friendly conversation. Yeah, it's just like a normal
Yes.
conversation. Don't take it too personal. That so when I'm troubleshooting the problem and I'm giving a packet capture to you. So
Mm-hmm.
step by step example, a client cannot connect. Very simple problem. Yep, a client in the same subnet he can't reach. I mean, if he tries to ping, he can't ping, and there is no firewall or anything in the middle. It is just one switch. It's a VLAN. Are you from you? Okay, you are from security background. Are you okay with routing and switching question?
Yeah, yeah.
Okay,
Yes.
okay. So from the Wireshark, what do you look for the logs? This is very simple. We'll start with simple and go a little harder. Yeah. What do you check from the only from the Wireshark? So you don't want you should not use your what is that switch CLI just by looking into the what is that
Packet
just
capture.
packet capture. Yeah. What you will check.
In the packet capture, I will try to search the MAC address first. Okay, I will first I check the MAC address of source and destination.
Okay,
So
cool.
according to that, I check that MAC address in the packet tracer. Okay,
Mm-hmm.
as a source
Okay.
and destination. I
Okay.
will do as a filter as a
Mm-hmm.
source MAC address. Okay,
Okay.
so that
Okay.
way I can try to reach. If, for example, in the received packet capture, I
Mm.
am able to see the sender MAC address, but not able to
Mm.
see the receiver MAC address. So in that
Mm.
case, so need to check the physical cable of that destination IP address, means
Okay.
destination. Okay,
Okay.
then check their port related status, inform
Mm-hmm.
to next team.
Mm-hmm.
Second thing, if the packet is not reaching, yeah, another
Mm.
cause like VLAN mismatch. Okay,
Mm. Mm. Okay.
then also I can filter the packet capture with the VLAN ID. Okay,
Mm-hmm. Yeah,
so that
cool.
way
Yeah.
also I can, that way
Check.
also I can do that troubleshooting.
Check. Yeah. And additional, what about the ping? I mean, if you do a ping, we should expect the response code. Is it something it should say administratively filtered? It's an option if something ACLS or something is blocking, you can see that in the ICMP code. If you remember, we discussed this in the ICMP classes. There is an additional option there.
Yes,
You can
yes,
see the administrative filtered. If it is administratively filtered, then somebody is using an ACL, so your traffic is blocked. That's something additionally we check apart from just looking into the logs. Yeah. And also you
yes,
will see your ARP. Yeah. For my ARP request, do I see the ARP response track? Correct.
yes,
Yeah.
yes, correct.
Cool. Okay, Nilesh, fine. So let's go a little advanced now. So for example, if I want to
Mhm.
see the payload, where exactly I can see the payload option in my capture, in which particular header you can see that, and how you will use your Wireshark to see that value. If I want to see the payload, if user is sending some payload, And if you want to try something, troubleshooting something related to your payload, some latency issue, and you want to try.
About the payload, we can see the TCP UDP packet. Like if you select any packet capture,
Okay.
so we can see inside that TCP option.
But where exactly, in which particular header and parameter, do you know that?
Header and parameter.
It is actually
Like
right behind your the screen. You have that option. Right behind the screen. I'm sharing my screen and you can see that. Your actual payload.
left hand means towards your left hand side, you can see that option.
Okay. It's a TCP segment length, yeah? Can you see my screen?
Yes.
There. The TCP segment length is the field where you can see your exact payload. And also, if you want to troubleshoot your problem with a payload related, you can also make use of leverage your Nmap. Yesterday we discussed about Nmap.
Yes.
Yeah, you can do that. Cool. Yeah, immediately it will not happen. Yeah, you have to prepare for it. Not at all a problem. We're just trying here.
Yes.
And one more question here. For everyone, I mean,
Yes.
it's not only for Nilesh. It's like everybody can talk. It's not only limited to Nilesh. I gave an unmute permission for everyone. You can also join the discussion. If I take a capture from a PC, can I see the VLAN ID?
No.
Amazing. Because from the PC standpoint, it doesn't understand, it doesn't work on layer 2. Yeah, it works only on layer 3. We don't see any packets. You have to take from the switch to see the VLAN level details. Very good, Nilesh. So what
Yes.
about, okay, let's go a little deep about, okay, if there is congestion in your network. So what is the quick filter we will use in the Wireshark to see the bad packets?
So at
It's
the
fine.
below you can see
Yeah.
at the below you can see there is a
Expert.
stream communication.
Yeah.
Yeah, expert
Expert. Yeah.
expert option.
Correct. Yeah. Here. And also you can give tcp.analysis.flags.
Yes.
tcp.analysis.flags will give you all the congested and the back packets like this. See here now you can see your retransmission, your duplicate acknowledgement. Yeah. From here you can troubleshoot your problem. Okay. So now it's common for everyone. You guys can open up you can unmute yourself. Everybody can answer this and can try, no problem. So if you're dealing something with the retransmission, so say for example here 10.1.2.1 is doing a retransmission. What does it exactly mean? Who is not responding here? Is it 10.1.2.1 or 10.1.1.2.4? Who is not responding here? What
Destination
is
is not responded.
Okay, cool. 10.1.1.2.4. Okay, fine. Got it. So in this case, what could be the problem then? So Wireshark is showing that it is a retransmission problem. So what is the next step? What is the next troubleshooting you guys will do? Is it you guys will check for the gateway of it? First, let me try to ping the gateway of it. I'll do a trace route, right? Do I really have a routing? But because this generally happens if there is no routing. Okay, so you don't see the retransmission and you see the reset. So that proves that my routing is good. Is it something with an ACL? Can I conclude a problem like that if I'm troubleshooting a problem?
Yeah, in that
Yes.
case,
Hmm.
I have to the destination end, and I got the same issues earlier. Packet was stated, so we changed the server.
Okay.
Means the server ARP was not responding. The
Okay.
packet was resetted. So we replaced that the hardware box, I can say. After that, it was working fine.
A little bit adjust your mic, Vital. I think it is bit low. Yeah.
Sure. Okay,
No.
in that
Hmm.
case, I will be check with destination and server.
Hmm. No, I mean the reset happens. Then does it prove that do you have a routing?
Yeah. Receipt means that three-way handshaking is not happening properly server to the
Hmm.
client to server. Okay, so mean the
Okay.
destination is not sending the proper packets. So
Hmm.
in that case, we will check with that the server or sometimes the applications has some issues. So application
Hmm.
maybe not responding. So in that case, I will be check with that the destination port is up and that should be up and running.
Hmm. Okay.
So there are
Okay.
actually multiple scenario. Let's
Hmm.
example talking about the retransmission.
Hmm.
So retransmission means the three-way handshake is not happening.
Hmm.
Uh, so why it is not happening? Due to some latency, congestion, packet loss between source and destination. The middle of the firewall creating some.
Oh, okay. This is actually a good answer. So I'll ask you now. So you see the
Mhm,
three-way handshake in the beginning, but you see the
mhm,
retransmission in the middle. So
mhm.
there is a latency. But if I try to
Yes.
establish a connection, but I can't establish the connection at all, and I can keep seeing the retransmission, what could be the problem here?
Yeah,
So it in that. Yeah. Yes, yes, Vittal.
yeah. Sorry to interrupt you. Actually, there I got the same issues earlier. So
Okay.
from the uh, 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 that TLS certification upgraded means the destination end uh, and the LB end certification upgradation was happened. Okay, and
Hmm.
I was in analysis and I got to know that there was a issue with that upgradation has been happening in the backend server also. So
Mm-hmm.
also we getting these types of the issue.
Okay. Yeah, I mean, as Nilesh and Vital said, I mean, and top of that, Nilesh, yeah, as you said, see, if there is something
Yes.
connection broken in the middle, you see retransmission, and it tries to
Yeah.
send, and your connection may establish, then it is not a problem. But if I see only the retransmission, definitely I don't have a route. I can't reach that particular destination. That is a problem. The destination is not responding to me to initiate my three-way handshake, right?
Mhm. Yes.
Okay, and say for example, now I
No,
I
sorry,
Another.
see. Mm, yeah,
sorry,
yeah,
sorry.
tell me.
In
Yeah,
this case
yeah.
means you mean say that when if in my the firewall we are not getting any the traffic, right? So that means there is a routing issue, right? So
If I don't see the, I mean, if I see only the retransmission, I don't even get in a single acknowledgement packet back from the recipient or from the peer, then it is a
Since
problem with
initial
the routing. Yeah.
routing. Yeah.
yeah, yeah. Okay, okay.
So another conditions like the app related, like if the source and destination source is trying to access the 443 port to
Hmm.
that destination. So
Correct.
the app is not app something app happening is the crash happen, a server
Hmm.
crash, or a
Yeah.
server having the buffer related issue. Okay, the
Okay.
port related issue. Sometimes the server upgrade their patches, so that time the server not giving the response to a receive request. So there
Yeah.
are multiple scenario in between.
Scenarios, absolutely, absolutely. We can't come to a conclusion just with
Yeah, even the
one
LBs is
troubleshooting.
not the responding. LB is the virtual IP VP is not responding also, right?
It
Well,
depends scenario.
Yeah,
yeah.
yeah, yeah.
Vithal.
Yeah, correct. Yeah.
And what I would see, and top of that example, if I try to reach a destination, say for example, if I try to reach a destination, if a retransmission is completely happening, And also I would suggest do a trace route and take the capture and see the TTL where exactly the packet dies. So from there, what it helps is that you can talk to the concerned team. Maybe that particular subnet may be owned in the load balancer or anything. You can tell them, see, I can reach to this IP address for firewall and after the firewall, the packet is not routed. If I don't have a route, even the Palo Alto or FI, the application can be hosted anywhere, right? So if I see where exactly the packet is dying with the help of TTL, I can figure out that problem. I can't just stop with retransmission, correct? If I do a trace route to that particular destination, I know where exactly it is dying. In this case, if you take
Yes.
this is between two different subnets. 10.1.2.1, it is 10.1.254. But if I do a trace route and if I try to find, I can know exactly who is responsible and how I can troubleshoot. With just retransmission, if I go and tell the server team that I can't reach this, even they have no clue. But what we should do a trace route and we should see where exactly it is dying. From there, you have to do your troubleshooting. So that
No,
helps
but
sometimes. Okay, you can find
no,
you might have multiple switches or you might have a big network, right? Because we are all working like that. We are not playing with it. Here it is just a lab. Hardly we are using 4-5 devices, but in your real network it is not like that. Everybody's handling like 50 sites, 25 sites. So in that case, always don't just stop with just look into the retransmission, don't come to a conclusion that it is not routed. The troubleshooting started here. So it is retransmitted. You have to do a trace route, check for your TTL, how many hops it goes, where exactly it is dying, talk to the concerned team. Then you have to continue your troubleshooting until you find your problem. As I said, Wireshark is one sweet spot, but it can't give you the answers right away. From this, you have to apply your logic. So this helps first. Okay, the server is not reachable. Say, for example, you don't see a retransmission and you see the reset. So there is a routing, but who is doing a reset? Is it a client or the firewall? So the ports are only thing the firewall can block, correct? So it can be a firewall or in computer. So who is doing the reset? That is important. Is it me client resets the connection or the server resets? So you will go ahead and check. If the client resets, you can check your firewall on your end. If the server resets, you have to check your firewall and the end computer on their end to check for your ports. So that's how, see, this is using the Wireshark. We have to apply the logics to figure out a problem, but you can't come to a conclusion. But this will give a exact picture, okay, where you have to look for. That is my point. Yeah.
no, but in that case, we require pickup from the both end, right? The server side and also and the destination,
That
right?
is
Source and the
that is
destination.
yeah, that is recommended. But you guys just by looking this capture, you told the destination is not responding. That is true because we are doing a retransmission, but I don't get a reply from the destination. So it is apparently that it's a problem with the destination. It's not my source because I see traffic going out for other destination. So I am successfully establishing my HTTPS connection or whatsoever you want to try. Your connection is happening from your PC, but the retransmission is not happening from the destination. So for this, you don't need the, what is that, destination PGAP. That is helpful if you get it. Say, for example, when you need packet capture on bidirectional capture, I'll tell you. I think Leilish is also working on, what is that, load balancer. Vital is also using a load balancer. If a client is trying to establish a connection with the load balancer, the first traffic hits your VIP, right? We have virtual IP. Then your virtual IP connects back to your backend servers. So in this case, if you take a capture, you can see the HTTP, you can see your TCP communication only between the client and the VIP. You don't know what is happening between the VIP and your backend server. So in that case, either you have to take a packet capture from, sorry, not either, you have to take packet capture on both sides. One is your client. The other thing should be at least your backend server. That is well and good. Or else at least from the Netscaler, you have to take a capture for your backend server. So in that case, it is very mandatory. because you have two TCP connections. So in that case, only with only with what do you say, from the client side you can't do anything. So you have to take a capture on your NetScaler and client, or else from the backend server and the client. So apparently the backend server cannot talk to the client directly if you have your NetScaler, you mean your load balancer in the middle. So you have to take a capture like that. So it depends on the use case. You guys got the logic when to use bidirectional packet capture?
Yes.
Yeah. So in that case, you have to do like that. Okay, now let's go to some additional topics. What else we got? Let me quickly open the course content here. What about Santosh? Do you have any questions, Santosh and Asad? Let me open this up.
I use your IPOP tactics for utilization issue.
Ah, okay, that's so cool. FIPERF will give you a very good insight about that. This is for Wireshark. Oh, this one, okay. Yeah, for a congestion, let someone talk about. Yeah, Santosh, you had some question.
Yes, Praveen, as you told that earlier, there are the while working in the LB via LB
Mm-hmm.
as a file, there are the two session will be established from client to the FI and FI to the backend server.
Yeah, yeah.
But some few cases like there are the lack of hits between client to the FI to the backend server also, but few hits is dropping. In that case, how we can conclude which session from the client is reset has any or server resets?
I mean, what is the amount of drops? How much is it?
Like
I mean, just how many
it is
packets?
less than 5%.
Less than 5%. So you see your drops. So have you checked this interface errors, CRC errors? Is it something like that? Is it your
Yeah,
virtual or physical?
it's physical.
It's a physical. So when you try to ping, you see drops, or even for your TCP connection, you feel slowness and you see a lot of duplicate packets, duplicate acknowledgements. More, I mean, do you see any kind of TCP errors there when you troubleshooted that problem? How is your TCP errors when you establish a connection to it? See,
Not
when I see TCP errors, see, this is TCP errors like this. What is the amount of TCP errors? So out of this 1,815 packets, I see only 4%, 0.4%, not even 1%. So
right.
how much is it? How much is your percentage of your TCP errors like this?
I'm not remember exactly now. It is the 1 week back we faced this issue, and approximately it is like 2% or 3% that I
I mean, in the amount of total packet matters a lot. So here, say for example, out of 1,800 packets, if I see 2% is also too high. We had this session long back, if you remember, the percentage what you get of this TCP errors, that matters a lot when you have especially this when we are dealing with this congestion. That is very important to compare. And do you see any kind of TCP zero windows or window errors? Do you see something like that?
No, not. I'm not remember exactly that all the details.
Okay, no problem. You can go through that. That's why we have the recording. You can go through that. There we covered a lot about this TCP errors. See, if you see a lot of retransmission, especially I'm telling you, if you see a lot of duplicate acknowledgements, that is because of a congestion. But it should be, that's what I'm telling you. If you just look for few duplicate acknowledgements and don't conclude that it is a problem. See, there are always a little bit congestion, and you see this duplicate acknowledgement. But how many duplicate acknowledgements you see? Example, if you see 100 duplicate acknowledgement, here it is. What is that? This is duplicate acknowledgement. Where is that? Especially if you look for duplicate acknowledgement, how many duplicate acknowledgements you got here? So here I see this is duplicate acknowledgement for this 21 packet. This is 111. So this is not a big deal. But if you see 21/1, 2, 3, 10, 100, something like that, if it grows like that, then it is a problem. So that's how we see. First, you have to check, is it my interface error or is it something with my TCP connection? If you want to really find your TCP problem, this is how you have to figure out. You have to see how many duplicate packets you see. Do you see any TCP window error? Anything related to TCP bad packets? Then you have to come to a conclusion. Why it is. And have you checked your round trip time when you discussed about this SYN/SYN ACK back? When you see for your SYN/SYN ACK, what is your round trip time? See, this is SYN and this is SYN ACK. This is 113 milliseconds. So what is your milliseconds? You have to see that. Is it going beyond 1 or 2 seconds? And even in the middle also, is it your HTTP request for that, the response is bad? If you say generally it's a packet error, mostly it is with network congestion. Generally, if you see there, you see a drop. It is a network congestion. But if you don't see any drops, but you have problem with your TCP connection, then you have to check for the other parameters.
Okay.
Everything collectively you have to troubleshoot.
Okay. I'll research on that once again. I will validate, then I'll come to know, or I'll get back.
Sure, no problem.
And
yeah,
I shared one WhatsApp message that command explanation I want, because when we are packet capturing in the F5, we are decrypting, and but my lead is not explaining that command output, so that I want to decrypt.
You want to, okay, is it something you sent
T-sharp is doing. But
Oh.
see, something number is, that is the file name.
Oh, this is a T-Shark. You're using T-Shark. Okay.
Through T-shark is putting this command in T-shark, then that output file is opening into the Wireshark. Till the time that TLS or SSL will not be, we cannot visible packets.
I will go through this and I'll get back to you. Yeah.
Okay.
Yeah.
Hey,
Sure.
Santosh, could you please share that command in our group?
Sure, I'll share it.
Yeah, thanks.
What else? I had something to ask for. So, okay, if somebody is asking a question related to a DNS, if you have some problem with your DNS latency, how do you guys check your DNS problem, DNS latency? Anybody got an idea about how to troubleshoot your DNS problem? Especially it happens with the DNS slowness. Let's take DNS slowness and the DNS resolution. So how do you troubleshoot your DNS problems? And with Wireshark, how do you troubleshoot? Vital, you want to say something?
Yeah. In that case, we have to check that DNS lookup is happening or not. Right?
Okay.
The name to IP or IP to name should be resolved.
Okay.
Another steps looks like time between sending a DNS query and receiving a response.
Correct.
That one is the one clue.
Yeah. Correct. So you can filter this with the DNS.time. You can give greater than 1. So everything takes more than 1 second for the response, you can find all the packets there. And also we got a couple of gap filters I think we can use on top of that. You can make use of this to see who is your authoritative server, who is responding back, and all this additional details you can see apart from your normal troubleshooting. And also the very basic thing is if your local DNS server is up and running, you can ping and check, and you can, if your destination is, I mean, if you can't resolve your host name, you're trying to resolve, if you can't resolve it, try to change to the public DNS and try to resolve what is happening. And when in the Wireshark, you should see your actually DNS request, you should get a response back. That's it. It's very simple. I mean, if you don't get a DNS response, so you have to check your servers and other stuff. Yeah, your authority server and everything. Do you have your record for it? It is local or external. And also you can make use of MX toolbox. If it is an external record, you can try to resolve it using MS record. And especially when it comes to Wireshark, when you're troubleshooting, you can check for your DNS latency. And as I said, you have some other additional headers there. You can pop in the authoritative name server field in the column and you can troubleshoot. Yeah. Okay. Then one final question that's most interesting, I think, for every firewall and the routing and switching team. They ask this question, right? So how can you walk me through the step-by-step process of IPsec VPN tunnel? So even I had this difficulty for 4-5 years back. I remember somebody asked me, I was very blank. I mean, I said we will be using this key encryption hash on both end. I will check. But he asked me very simple. That made me to learn IPsec tunnel. He asked me very simple question. Can you help me packet by packet how the IPsec tunnel happens? Can you explain the phase 1 and phase 2? Can you explain me the modes and the whole mode of operation? Then something it inspired me the question. Then I learned this IPsec tunnel. So do you guys anyone interested here to talk about the whole process of IPsec tunnel?
Yeah, the phase 1, phase 2, you explain very well.
Yeah.
You gave the good knowledge.
Correct. So we have to start something like M1 message, main mode message 1. The client proposes 3 parameters, key, encryption, hash. So I should get back the same thing from MM2 message, key, encryption, hash. So once this proposal happens, and I should match the pre-shared key, this happens in M1 and M2. And in the M3 message, actually your Diffie Hellman kicks in, right? It creates the both combines together and it comes with the key, right? Until this point, nothing is encrypted. After this M3 message, the Diffie Hellman will share its shared secret key. And in the M4 message, it shares the shared secret key. So both Diffie Hellman group matches. Everything is encrypted after M4, and M5 and M6, you can't see anything. Everything is encrypted at this point. So everything, the proposal and everything has happened, and your phase 1 is over up to main mode 6 message. Then comes your quick mode message. There your actual phase 2 tunnel builds in, and your interesting traffic. Your what is your interesting traffic? If it is a routed mode, you don't have any ACL. This is a route-based VPN. But if you are using any kind of ACL, that is policy-based VPN. So you should see your quick mode active or idle state. Then you should see the 3 quick mode messages. Followed by that, if your actual transport is happening, your packet is properly sent and received in your IPsec tunnel, you should see all your ESP packet, and also you should see your SPI information. I think this level of information is more than sufficient if you give to someone else. If you talk about VPN, I think they will not ask you more questions about this. We covered a lot with this. Yeah.
Yes, Praveen.
Yeah. That's it about today's session, and all the best for everyone. Keep in touch, and you can ping, share your knowledge, and yeah, every batch is an amazing batch, but especially this batch is they're very understandable and they're very cooperative, and you guys really asked fantastic questions, and I hope I tried my best to do. So not everybody can give answers for all the questions, but I tried my best and I shared my experience. Even I learned a lot from you guys. I mean, from everyone, from different scenarios you guys explained. So that's so cool. So I enjoyed this batch very much. So all the very best. And my piece of advice is everybody is very busy with our work, but spend some time. I mean, discipline is the key for that. So we can't be stick to the same thing forever. Even though if we are rushing up, we are doing stuff. At least we spend some time to go through what we learned and leverage your Wireshark skills because it helps for every platform. It is not limited to routing and switching or security. It helps for your cloud. Believe me or not, I mean, I can learn AWS and everything. I mean, I'm doing a self-study. It is this Wireshark helps me a lot, especially when troubleshooting. I got stuck, 5-6 years back. I was very bad in troubleshooting. That is just because I can't understand the fundamentals of that. Even though we know sometimes, right? We know SSL and everybody will look for an SSL. We are, but the problem is we are not going deep level. To go deep level, Wireshark helps you because for every packet level, if you learn along with your theory, that inspires you, that makes you more interest. You feel so in how to say that you will feel so interested to learn something. But if you just learn theory, I mean, if you just do practical, it will not help. So I think Wireshark is such a sweet tool where you can leverage your learning. That helps you to learn a lot. So I mean, if you're not using Wireshark, I'm telling, maybe you might be doing your debugging. It may help in the parallel to some. I mean, I think someone said about that, Setu. That's true. You can do your debugging and can fix a problem, but to understand the concept, I think Wireshark is the best place where it helps for your learning. So you can, learn deeper with packets. So that's my take and experience with Wireshark. So all the very best, and try to learn whenever you get time. Just go through that, and I hope this will be helpful for your career. And if you have any other questions apart from this, I'm happy to answer you guys.
Thanks, Praveen. You have given the good knowledge about the packet tracer, Ms. Wireshark.
Okay.
And thanks for that tunnel related. Like I
Uh,
gave you version 1 to
Okay.
how
Okay.
we can see that in the packet capture.
Okay.
So it was very amazing.
Okay. Thank you. Thank you so much for your feedback, Nilesh. Yeah, matters a lot. Yeah.
Praveen, from my end, I'm more than coming to troubleshooting call due to the help of this wired set, and I'm giving them the solution. This is happening from your end, and this is happening. They are also the surprise.
A little adjust your mic, Vital. I can barely hear you.
Connected. Okay, I'm audible.
Yeah. No, you're fine. Yeah.
Okay. So during this is the training, I jump to the P1 call. Okay, I did lots of the packet capture analysis. Okay, and after that, I have resolved many issues due to help of this is the packet capture, and
Okay.
everyone was the surprise of how you
cool.
know that like that. So this is the means the very powerful tools where we can fixing our the production issues. I can say application production or the whatever the issue we can understand.
Okay. Yeah. You're right. Yeah. Okay. Cool. Keep doing that. Yeah. Keep doing that. Learn very well. Explore more and troubleshoot better. Be a rock star in your team. Yeah.
Yeah. Thank you.
Yeah. No problem. So then all the best, Asad, all the best, Nilesh, Santosh, Vital, and whomsoever the people who have not joined. Thanks everyone for your wonderful support. So keep in touch and yeah, all the very best for your career. Yeah. Thanks everyone. Bye.
Yeah.
Thanks, Praveen. Bye.
Thank you.
Thanks,
Bye.
Praveen.
Bye.
Yeah. Thank you. Bye.
Yeah, sure. So bye, Santosh. Bye.